Number 7, x minus 2y is equal to negative 3. Subtract x from both sides of the equation. On the left side, if I was subtracting 2y, that's the same as adding negative 2y, so I still have negative 2y when this first term goes to 0. And over here I have negative 3. I'm going to write it here, negative 3 minus x is the same as negative 3 plus negative x. So I can write that as negative x plus negative 3 if I want to keep the variable term first. Then I divide both sides by negative 2. And we get y equals negative x over negative 2 plus negative 3 over negative 2. Now this is a little different. Negative divided, I'm looking at the constant term right now. Negative divided by negative is positive. 3 divided by 2 is 1.5, but we haven't been converting to standard form yet. We might as well just keep it as 3 halves. We know that's 1 1/2. And here we have a negative divided by negative is positive, so this is the same as x over 2, which is just 1/2 x. So 1/2 x plus 3 halves. So y equals mx plus b. We have a fractional b for the first time ever, but there's no reason that the line couldn't intersect at a fractional point. In fact, it's almost certain that it would if we're doing things randomly. There's a lot more fractions than there are whole numbers or integers. So b equals positive 3 halves. Well, that's okay. That's just 1 1/2. So positive 1 1/2 is where the line intersects the y-axis. And then m is positive 1/2. So delta y over delta x is positive 1 over positive 2. So from this point, I move up 1, which puts me at 2.5, and right 2, which puts me here. And that line's going to intersect at P.